Here I go. So the moving shadow problem says we have a woman that's 5 feet tall, not particularly tall, and she's walking at a certain speed toward a street light that is 20 feet above the ground. It says, find the rate of change of the length of her shadow at a certain time. And then it says, at what rate is the tip of her shadow moving? Okay. So I'm going to try and draw a sketch because I think because there was no sketch and you haven't seen this kind of problem, there's my 5 foot tall woman. Wait, you don't like her outfit? Come on. She's walking towards a street lamp which is 20 feet tall. So let's see, 5, 10, 15. There's my street lamp. You guys with me? And we're supposed to find at what rate the length of her shadow, is that what they said? The length of her shadow. Where's her shadow? That was part of the problem. See, the light shines on her, just like it shines on everyone. But then, like, just past her, from here to here, there's a shadow. Are you with me? Actually, it kind of looks like this. Right? That's her shadow. Right over here. And I'm going to call that X, the length of her shadow. X is the length of her shadow in feet. Why did I choose feet? Well, because they told me she is 5 feet tall, and they told me this light is 20 feet in the air. How many are with me so far? Okay. And what is it that we're actually supposed to find based on this schematic? We're supposed to find, that's the problem. Trying to understand what you're supposed to find. Here, let me go back to the text. Where'd it go? Here? Moving shadow. It says, what is the rate of change of the length of her shadow? In other words, find what? Find dx dt when something else happens. When what happens?
She's 15 feet away.
She is 15 feet from the street light. Now hold on a second, just so you guys understand. I labeled this X because, do you guys understand the length of the shadow is going to change? Sure. Matter of fact, right when she's directly under the street light, it'll be 0. And it'll start growing again. You guys with me? So because she's walking towards the street light, the shadow changes until it gets to 0. Let's call this distance Z from the woman to the light. Is that okay? We're supposed to find dx dt when z equals 15. Guys with me? And there's only one other thing that they told me in the problem. What's the other piece of given information? Oh, here it is. She walks 8 feet per second toward the streetlight. How would I express that? If she's walking towards the streetlight, what does that mean is changing? Yeah. So I might say dz dt, we are given that dz dt is equal to, they said 8. Why don't I say negative 8? Do you understand why I would do that? Why would I say negative 8 feet per second? Well, because z is getting smaller. 8 feet per second small. Are you guys with me? So actually, if she's only 15 feet away, less than 2 seconds from now, that shadow's gone. Right? It'll take her less than 2 seconds to cover the 15 feet if she's going 8 feet per second. Question? No? the trick now is, how do I set up a related rates equation? I need to see how dx dt and dz dt are related. For that, you have to know how x and z are related. And what's the key to this problem geometry-wise? What? You see similar triangles? I used to take my geometry class in high school out to go measure. We would measure the height of the goalpost. There'd always be some kid that was 5 feet tall. They're sophomores in high school, so we'd get that person, and then we'd line them up, and we'd do this problem basically. So yeah, the triangles that are similar are this one to the big one. Okay, and because those are similar, you can say that certain sides are in proportion. So I could, for example, say that x over 5 is equal to, well, now I have to do the big triangle. What do I put over 20? X plus z. That's right. X plus z over 20. So there's an equation. And what am I going to do eventually then? Take the derivative of both sides with respect to time, t. And then you'll have a related rates equation. I wouldn't do it yet. I would do this. I would mess around with it a little bit, 20x equals 5x plus 5z. So 15x is 5z. So I'd say, hey, z equals 3x. Well, that's kind of interesting. Once you know that, you know how long her shadow is, right? Z is 15, and her shadow is 5. That's actually the same length as she is. It's right when it's at a 45-degree angle is when they decided to stop the problem. Out of time, guys. You can solve the rest at this point.